Alrighty, kids. Assalamu alaikum. So this right here is May June 2019. Let's begin with the first question. So the first question says student determines an approximate blah blah blah. ठीक है. So heating चल रही है, probably got something to do with the specific heat capacity of water maybe. जो important आपकी values हैं उनको आप एक highlight कर लें ताकि आपको बाद में याद रहे कि ठीक है, you need to consider these values. So this 100 grams right here seems important. ठीक है. Part A पर आ जाते हैं. Draw a voltmeter symbol on the circuit diagram of figure 1.1 to show the voltmeter. ठीक है. So parallel में लगेगा तो it's going to be something along these lines. इस तरह से आप हीटर के साथ parallel में you can attach the voltmeter. Second is the reading on the thermometer at T is equals to 240 seconds. Read the temperature recorded in table 1.1. So this temperature looks like a 41.5. तो उसको यहाँ पे हम लिख देते हैं 41.5 डिग्री सेल्सियस. अच्छा, current जो है, we have 4 amperes of current, we have 14.8 volts of potential difference. Now the question says, state why is it important to ensure that heating coil is completely immersed in water. जाहिर सी बात है, we want all the energy to be transmitted to water, hence your heating coil needs to be immersed, completely immersed in water. अगर वो completely immersed नहीं होगा, there will be loss of heat. So to ensure that all energy is transferred to water and to prevent heat loss. ठीक है, and to prevent and to prevent heat loss. ठीक है जी, heat loss हमने prevent करना है. Stir the water before recording each temperature. So heat is distributed uniformly. So heat is distributed uniformly and water is at a constant temperature. वरना ये होगा कि अगर आप स्टर नहीं करोगे तो लेट्स से फॉर एग्जांपल पानी है, तो अगर आप स्टर नहीं करोगे, यहाँ पर हीटर पड़ा हुआ है, तो इस साइड पे जो आपका टेम्परेचर होगा वो काफ़ी ज़्यादा होगा. ठीक है, अगर इफ़ द हीटर इज़ राइट हियर देन दिस साइड राइट हियर इज़ गोइंग टू हैव अ मच हायर टेम्परेचर वर्सेस दिस साइड राइट हियर which may have a lower temperature. तो इस तरह के situation से बचने के लिए you stir it so that heat gets uniformly spread and you've got a uniform temperature all around. ठीक है, तो ये uniform temperature, uniform heat spread के लिए आप इसको stir करेंगे. ठीक है, so let's say go to part C, part 1. So theta, the temperature on the y-axis and time in seconds on the x-axis. That's cool. अच्छा, so the question says this right here is important, that you start the x-axis or the temperature, sorry, the y-axis, the temperature axis at 20 degrees Celsius. Cool, we can do that. So this right here, my bad, and this right here is going to be 20 degrees Celsius and 0 seconds. ठीक है जी. Now let's get our values. So this right here is an increments of 60, so that we are good with that. 0 से लेके 360 plot करना है, ये 20 से लेके approximately 50 तक plot करना है. All right, so you've got 1 2 3 4 5 6 7 and 8 boxes. Now in 8 boxes I need to fit 360 seconds. I'm gonna go with 50 seconds each box. सही है, 50 times 8 is 400, तो 400 की रेंज में आपका 360 सुकून से फिट हो जाएगा. So you got 200 over here, 250, 300, 350 and 400. All right, so to be able to fit through 0 to 360 seconds, you need at least 50. Of course, you can go with 100 boxes, sorry, 100 seconds per box as well. But then you probably will lose a mark for the correct linear scale. Why? Because you won't be using more than half of your graph paper. So if, let's say for example, I take one box is 100 units, so 400 will be here, and your graph will only be towards the left of this 400 because the maximum time reading is 360 seconds. So essentially you'll be using less than half the graph. So usually you lose points there if you are using less than half the graph. So we've got 1, 2, 3, 4, 5, 6, and 7. So you've got 7 boxes in which you need to fit values between 20 and 50. So maybe I take 10, but that's again not going to be as accurate as 5 is going to be. Because if I take 5, I'm gonna go to 50 over here, and I see about the 48.5 is very close. So that's what I choose to go with. If I go with 10, I'm gonna get 30, 40, and 50. Again, less than half the graph. You're still gonna face the same problem where you'll lose a mark for the correct scale because you're not using half of the graph paper provided. So 25, 30, 35, 40, 45, 50, and then 55. Of course, the 55 is of no use to us. Why? Because our maximum reading is 48.5. Now let's start plotting the thing. If I'm not wrong, the first value was 21.5, 27.32. 21.5, 27.32. So 21 is here, 21.5 will be here. So 21.5 and 60, no, 21.5 and 0. Sorry, my bad. So 21.5 and 0 would be somewhere over here. Let's just clarify that again. So 21 and then 21.5 would be here. At 60, it was 27, and at 120, it's 32. At 60, so this right here would be 60. It's 27. So 25, 26, and 27. And at 120, it's 32. So 110, 120 is going to be over here. So that's going to be 27 ke baad we have 32. So over here we've got 1, we've got 2. So this right here is going to be 32. Then after 32 we have 37, 41.5. So at 180, which is going to be somewhere over here, we have 37. So 1 and 2. So you got 37. And then we have, so after 37, we have 41.5. So at 240, you got 40, 41, and 41.5. Then you had a 45.5 and a 48.5. Cool. So at 240, then at 300, you've got a 45.5. And at a 360, you've got 48.5. So this right here is 50, 49, 48. The 48.5 is going to be over here. So now because the question says you need to draw a smooth curve of best fit, so the curve is important. That's what we need to draw. We need to draw a curve. Okay. The curve बनाने के लिए what are we going to do? That's very simple. First, let's just freehand this. So I'm just going to use a very light hand to do that. Now I can see a curve at the end, but I cannot see that good of a curve at the beginning. Okay, so no, drawing it from the end is not going to do me any good. So मैं इसको आखिर से बनाता हूँ. So I've got almost a straight line. ठीक है जी. I'm gonna skip this bit, or yep, that's better. All right, so yeah, this right here is giving me a better curve. So now we can draw this with a firmer hand. So the graph that we want to draw over here is going to be something along these lines. ठीक है जी. So अब जाहिर सी बात है, drawing on a screen is not as easy as drawing on a piece of paper, but I hope that I've drawn it relatively okay. Maybe ये थोड़ा सा नीचे जाएगा. Maybe this right here goes down a little, but other than that, I see an okay curve. ठीक है, you've got one point that's below. The other points are almost on the line, so we should be good with that. Next question. Use your graph to calculate the rise in temperature delta theta of the water in the first 200 seconds. 200 seconds पे temperature note down कर लेते हैं. It's almost 39. सही है. 39 जो है वो आपका temperature है at 200 seconds. Of course, it was 21.5 at first, so we can just go with 39 minus 21.5, and that's going to give me 17.5 as the correct answer. So 17.5 degrees Celsius must be. अब जाहिर सी बात है, for everyone the answer is going to be slightly different. ठीक है, तो अगर मे बी लेट्स से फॉर एग्जांपल आपका 16 आ रहा है या 16.5 आ रहा है या 18 आ रहा है, तो probably they're going to be okay. Marking scheme is going to have a range of values which are going to be correct. Say there is not going to be any specific value that's going to be correct. It's got to be a range. Then the question says calculate the thermal energy supplied by the heater in the first 200 seconds. तो वो हमने values ऊपर highlight की थी. It was 4 amperes and 14.8 volts of potential difference. So that's what I'm going to use over here. The potential difference is 14.8. The current is 4. The time, of course, is 200. So your answer must be what? Your answer must be 56 and 59.2. Though 59.2 would give me 118.4. So times two decimal places ahead would be 11,840 joules. ठीक है, so 11,840 joules जो है वो आपका आंसर होना चाहिए. यहाँ पे of course the unit is not given, so you are going to write the unit joules. जाहिर सी बात है, आप ऊपर अगर देखें तो आपके आंसर्स जो हैं वो ज़्यादातर 2 SF के ऊपर, आपकी वैल्यूज़ जो हैं वो 2 या 3 SF के ऊपर मैंशनड हैं, तो यू आर गोइंग टू आंसर at 2 or 3 SF as well. So this right here is at 2 SF, this right here is at 3 SF, so that's exactly what we are going to do. This right here is not 3 SF, so you either go with 12,000 joules or you go with 11,800 joules. ठीक है, दोनों में से कोई भी एक जो है वो आपका acceptable answer होगा. All right. Then we have calculate the value for the specific heat capacity of water. Use the mass given in the start of this equation. We mark the mass, which was 100 grams. C is what we want to figure out. Delta T, we already figured out, was 17.5. That would be equals to the energy given to the water, which we figured out to be 11,800 or 12,000. But you're not going to use either value. हमने actually calculate किया था 11,840, तो that's what you're going to use over here. आप कभी भी approximated values को आगे वाले parts में, you will never use approximated values for your calculations in the for following parts. All right, so parts that follow the previous parts, you're never going to use approximated values. You're always going to use exact or accurate values. So the value of C is going to be equals to how much? That's going to be 118.40 divided by 100 times 17.5. So of course I'm gonna have to use a calculator for that. So 11,840. So 11,840 divided by 17.5. That gives me 6.76. So 6.76 must be, or somewhere around that value would be the correct answer. ठीक है जी. तो that would be the specific capacity of water. जाहिर सी बात है, we know that the specific capacity of water is actually 4.2 joules per gram. So that's exactly what the question is saying. The specific capacity of water is 4.2 joules per gram per degree Celsius. Examine the apparatus set up in figure 1.1. Suggest one practical reason why your calculated value in C is accurate. तो जाहिर सी बात है, we haven't accounted for the heat loss. So जाहिर सी बात है, heat loss could be from if we go to the diagram before, yeah, so आपके walls से जो है वो heat loss हो सकती है, जाहिर सी बात है. सही है. So heat loss from both the walls. Of course, heating water will cause evaporation. ठीक है. Heating water will cause evaporation, and if we know that evaporation has a cooling effect on objects, तो जाहिर सी बात है, that's going to have a cooling effect as well. So we can say that not accounted for heat loss, not accounted for heat loss and evaporation. Take care. So we haven't accounted for heat loss and evaporation. State 1 improvement. So insulate walls, use a lid, insulate walls, use a lid to cover the beaker, lid to cover the beaker. ठीक है. तो इस तरह से you can come up with a lot of different sensible answers. Suggest one reason why the temperature of the water stops increasing when it reaches 82. So आप heat कर रहे हो but वो temperature increase नहीं हो रहा. ठीक है. Another student repeats the experiment and forgets to switch off the heater at the end of the experiment. The temperature of the water continues to rise until it reaches 82 degrees Celsius and then remains constant. तो जाहिर सी बात है, योर heat absorbed by water, heat absorbed by water must be equals to the heat lost. It would be equals to what? Would be equals to heat lost. So there is no net gain of energy, and because there is no net gain of energy, you essentially have a stalemate kind of situation जहाँ पे the amount of energy that you're giving is being lost, so your temperature is not increasing, it's not decreasing. ठीक है. So this right here was question number 1. Let's go to question number 2. A student uses a ray box to investigate the refraction of ray of blue light as it passes through the glass prism. Blah blah blah. ठीक है. Measure the angle of incidence. तो looks like 30 degrees to me. ठीक है. So 30 degrees के आसपास. जाहिर सी बात है, you're going to have a protractor. तो आपको जो है वो protractor मिला, आपके पास होगा protractor. So you can use the protractor to figure out the exact angle. The angle of refraction is at x is equals to 19 degrees. Draw the refracted ray inside the prism. Mark with letter Y the point where the refracted ray emerges from the prism. Mark the normal point at Y. Take care. So this right here is going to be 19 degrees. This right here is the point Y where your ray is going to emerge. ठीक है. इसको हम यहाँ पे लिख देते हैं. To draw the refracted ray inside the prism, we did that. Mark with letter Y the point where the refracted ray emerges from the prism. We did that. Draw the normal at point Y. So we also need to draw a normal at point Y. So dotted line which is perpendicular to the surface. Did that. A ray emerges from prism at Y. Describe how the student can mark the path of an emergent ray accurately on a piece of paper. ठीक है. तो we have done this experiment before. इससे पहले वाले papers, इससे पहले वाले years में भी we have done this experiment. इसी चीज़ को वापस जो है वो यहाँ पे लिखना है. I stated कि there were a couple of YouTube videos which I've provided already. तो वहाँ से आप एक अंदाज़ा लगा सकते हैं कि इसको so how to draw a ray accurately on a piece of paper. If you haven't watched that video, please do, because unless you have that information, you won't be able to understand how to solve this question. ठीक है, वो information ज़रूरी है to be able to solve this question. So essentially what we are going to do is observe the ray from the other side, of the prism. Insert 2 pins. Now the pins have to be relatively far from each other. ऐसा नहीं है कि एक के बाद फौरन एक पिन लगा दी. No. Insert 2 pins around, yeah, at least. Let's take at least 5 centimeters away from each other. Such that each pin such that the second pin is behind the first. All right, and then remove pins and draw a line. So first you are going to insert pins. You're going to remove them. Insert pins how? They must be a certain distance away from each other. They must be right behind each other. And then you remove the pins and you connect the pinholes with a line through the pinholes. So draw a line through the pinholes. ठीक है. अब जाहिर सी बात है ये वाला पॉइंट जो है at least 5 centimeters away, not important. Place the second pin behind each other, not important. So the question is just saying कि भाई आपने जो है वो क्या करना है, आपने एक मार्क के अंदर जो है वो समराइज करना है कि what are you going to do. तो that's going to be very simple कि you're going to use pins, insert them in a piece of paper using or observing the ray, and when you remove the pins and you draw a line through them, you'll get the result. The result is going to be the line that you drew, the arrow that you draw will be in the direction of the ray. ठीक है जी. So this is how you're going to go about this. Question number 3. A student investigates the maximum height h to which a ball bounces after hitting a lab bench. She sets up her apparatus as shown in figure 3.1. All right, cool. Then the question says, on figure 3.1, draw the ball when h is equals to 55. So at height 55, it should be somewhere over here is where we are going to draw the ball. H is equals to 55. Labeling is always important, so please remember that. Draw the position of the student's eye placed correctly to view the ball at a height of 55. Now to remove or to not have a parallax error, it's going to be exactly perpendicular. So आपने यहाँ पे eye लगा दिया, ठीक है. So this right here is going to be the eye. It's not going to be over here. सही है. It's not going to be over here. Wrong. It's not going to be over here. That's wrong. ठीक है. It's going to be exactly parallel to not make a parallax error. वो ज़रूरी है बेटा. ठीक है. Then the question says she repeats the procedure 3 more times and obtains the following results for age 54, 57 and 53. All right. So अब सिंपल है कि हमारे पास एक जो है वो तो 55 था. सही है. and we need to figure out all her results. The all means we need to include the 55 as well. That was the very first one, and then she repeats three more times and she gets 54, 57, and 53. So your average is going to be 55 plus 54 plus 57 plus 53. 57 plus 53 is 110. Then you've got 164, 169, and 169 ke baad we've got 219. So 219 divided by 4 is going to give me 53.75. So I'm approximately going to write this as 53.8, और क्योंकि दो एस एफ के अंदर आंसर दिया हुआ है तो probably it's going to be 54. ठीक है? That's what my correct answer is going to be. So I hope that made sense to everyone. मेरे ख्याल में मैंने आंसर जो है वो गलत लिखा है. So 16 times 4 जो होता है. My bad. So this right here is going to be 54. And your correct answer is going to be 54.8 or 55. जाहिर सी बात है क्योंकि बाकी दो एस एफ के ऊपर दिए हुए हैं तो आपका सही आंसर जो है वो 55 होना चाहिए. ठीक है, दो एस एफ के ऊपर है, ये भी दो एस एफ के ऊपर है, ये भी दो एस एफ के ऊपर है, 55 सेंटीमीटर्स भी दो एस एफ के ऊपर दिया हुआ था. तो ऑफ कोर्स योर आंसर इज गोइंग टू बी एट 2 SF as well. Then the question says the student uses a meter rule graduated in millimeters. Suggest why her results are not recorded to the nearest millimeter. तो जाहिर सी बात है, in that case it's not going to be very easy to measure correct to the nearest millimeter, specifically when a ball is not going to just sit there कि भाई हाँ ठीक है आप measurement ले ले height की, मैं इंतज़ार कर लेता. Of course not. The ball's going to fall, then it's going to rise, and then immediately once it reaches its highest point it's going to start falling down again. So it's not, you won't have enough time to say कि अच्छा ठीक है कि ये इतना millimeters होगा, और ball आपका इंतज़ार तो करेगा नहीं. ठीक है. So essentially what we have, we can write is not enough time, not enough time. सही है. Ball, you can also say ball immediately starts falling down. Ball immediately starts falling after reaching maximum height. Reaching maximum height. Take care. So again, a lot of different answers are possible. But the most straightforward is कि भाई जाहिर सी बात है उसके पास accurate measurements का time है ही नहीं. ठीक है, तो जब accurate measurement का time ही नहीं है तो in that case जाहिर सी बात है we cannot measure it exactly. And जाहिर सी बात है कि अब the ball is not going to rise, go up and go down right besides the scale. बिल्कुल स्केल के बराबर में तो नहीं होगा ना. जाहिर सी बात है आप एक डिफरेंट एंगल से देख रहे होंगे, बॉल कहीं और होगा, स्केल कहीं और होगा. तो उससे भी जो है आप एक प्रैक्टिकल प्रॉब्लम दे सकते हैं कि भाई इट्स नॉट इजी टू रिकॉर्ड अ मूविंग ऑब्जेक्ट. ठीक है, सो आप ये भी कह सकते हो कि इट्स not easy to take measurements of a moving object. Okay, your object is moving, so it's not going to be easy to measure its height. Student but now drops the ball from a height of 10 centimeters. Suggest why she now finds the maximum height reach difficult to measure. तो अगेन जाहिर सी बात है आपकी हाइट कम है, आपकी हाइट कम होने वजह से आपका टाइम जो रिक्वायर्ड होगा वो कम हो जाएगा कंपैरेटिवली. अगर आप जो हैं उप्स माय बैड comparatively, if you are dropping it from a height of 10 versus if you are dropping it from the top or somewhere around 80, you had a lot of time to adjust and make sure that you are able to get the reading in time. यहाँ पर तो आपके पास टाइम ही नहीं होगा. So over here again your answer is going to be not enough time. You don't have enough time to take measurements. सही है. So we don't have enough time to take all the measurements to be able to figure that out accurately. I hope that made sense to everyone. ठीक है जी. Then we've got question number 4. A box contains an unknown electrical component. The component is connected to two terminals P and Q. A battery, an ammeter, switch, lamp, crocodile clips are connected as shown in the circuit diagram of figure 4.1. The unknown component is either a broken wire or a connecting wire or a diode. Describe how to use the apparatus to determine whether the component in the box is a broken wire. No current flows in either direction. Flows in either direction. Means, let's say for example, if we connect the crocodile clips such that this is clip, assume करें कि आप clip number 1 और clip number 2 यूज़ करें. clip number 1 जो है वो P के साथ attached है, clip number 2 जो है वो Q के साथ attached है. अगर आप उल्टा भी करते हैं तब भी करंट तो फ्लो होगा नहीं. Why? Because it's a broken wire. Your circuit is open. If you have a connecting wire, then of course current flows in both the directions. Current flows in both directions. आप crocodile clip 1 को P के साथ और 2 को Q के साथ लगाएं और vice versa. Because you have a completely closed circuit, your circuit is still going to work. If you have a diode, then of course current flows in one direction only, because that's the purpose of a diode, right? In one direction only. The purpose of a diode is to allow the current to flow in one direction only. So of course it's going to flow in one direction. The component in the box is a low resistance connecting wire. A second box looks identical but contains a high resistance wire. Describe how to use the apparatus to determine which box contains the higher resistor. So, all right. सो अब जाहिर सी बात है, हम लोग क्या करेंगे कि अगर आपके पास जो है वो हाई रेजिस्टेंस का रेजिस्टर है तो ऑटोमेटिकली योर करंट इज़ गोइंग टू बी स्मॉलर. ठीक है. तो वी कैन यूज़ द एम मीटर एंड द वोल्ट मीटर टू मेजर कि भाई हमारा कितना करंट जो है वो पास हो रहा है. एंड इफ द करंट इज़ लार्जर, योर बॉक्स हैज़ wire with low resistance, and if your current is larger, then sorry, if your current is smaller, then you have a box or a higher resistance resistor. So we can just simply say across smaller resistance, greater current flows. एंड अगर आप लिखना चाहें तो आप ये भी लिख सकते हैं कि across a larger resistance, a large resistance, a smaller current flows. A smaller current will flow. ठीक है. So it's all a difference of whether you have a larger current that's flowing or a smaller current that's flowing. अगर कम current जा रहा है तो means high resistance होगा. अगर ज़्यादा current जा रहा है means low resistance होगा. ठीक है. So this right here was question number 4, and that's the end of this exam. ठीक है बच्चास. So that's it for today. Inshallah, I'll see you in the next one. Take care. Bars out.